day everyone, so today we're gonna solve a problem in the chapter 8 of thermodynamics and heat transfer. So let's begin. A gaseous fuel with 80% CH4, 15% of N2 and 5% O2 on a mole basis is burned with the dry air that enters the combustion chamber at 25 degrees Celsius and 100 kilopascal. The volumetric analysis of the products on a dry basis is 3.36% CO2, 0.09% CO, 14.91% O2, and 81.64% N2. Determine its air-fuel ratio. So the gaseous fuel with a known composition is burned with dry air, and the volumetric analysis of products gases is determined. The air-fuel ratio is to be determined. So in your property table A4, so you can determine the molar masses of the carbon, the hydrogen, nitrogen, and oxygen. And so its molar masses are 12, 2, 28, 32, and 29 kilogram per kilomole. I want you to remember this since we will gonna use this later. So considering 100 kilomole of dry products, the combustion equation can be written as X quantity 0.80 CH4 plus 0.15 N2 plus 0.05 O2 plus A quantity O2 plus 3.76 N2, and its product is 3.36 CO2 plus 0.09 CO plus 14.91 O2 plus 81.64 N2 plus B H2O. So I want you to remember or take note this equation because later on we're gonna use this. So the unknown coefficients x, a, and b are determined from the mass balances. So as I have said earlier, you should take note the combustion equation because we're gonna use it here. So our carbon, so its fuel is 0.8 X and its product is 3.36 plus 0.08, 0.09 rather. So just divide the 3.36 plus 0.09 to the 0.8. Enable for us to get X is equals to 4.31. And for our hydrogen, so 3.2X is its fuel plus air and its product is 2B. So 3.2x, as you can see here we have an x, so let's just plug in the value that we got, which is the 4.31. So divide it by 2, b is equals to 6.90. And for our nitrogen, 0.15x plus 3.76a is equals to 81.64. So just plug in the value of the x and then sum it up and divide it to the 81.64 for us to get the 21.54. So let's just plug in the values that we already got, which is the x, the b, and the a. So this become 4.31 quantity 0.80 CH4 plus 0.15 N2 plus 0.05 O2 plus 21.54 quantity O2 plus 3.76 N2, and the product becomes 3.36 CO2 plus 0.09 CO plus 14.91 O2 plus 81.64 N2 plus 6.9 H2O. So from the equation earlier, we'll just have to divide it by 4.31 because 1 kilomole of fuel can be obtained by dividing it, and then we got 0.80 CH4 plus 0.15 N2 plus 0.05 O2 quantity plus 5 quantity 0.2 plus 3.76 N2, and its product becomes 0.78 CO2 plus 0.02 CO plus 3.46 O2 plus 18.92 N2 plus 1.6 H2O. And now we can able to solve for its air-fuel ratio. So air-fuel ratio is equals to mass air over mass fuel. So let's just plug in their value. and also the value of the fuel that we got earlier. Therefore, our air-fuel ratio is 37.1 kilogram air per kilogram fuel. So this is the answer that we are looking for, and I hope that you learned something from it. Goodbye and thank you everyone.